Training in Weld Quality Assurance and Quality Control. Section 6. Non-Destructive Testing. Topic 5. Principles of Ultrasonic Testing. The objective of this topic is to be able to identify the basic principles and applications of ultrasonic testing. Ultrasonic testing is a highly sensitive method used for detecting discontinuities found in welds and various other materials. It is used extensively in the welding industry for critical applications where quality is of utmost importance. The inspection method is rather similar to the sonar used by ships to locate submarines. The sonar device in the ship transmits inaudible sound waves which reflect off the submarine and are received by the ship as a signal on a screen. Ultrasonic testing of welds is performed in a similar manner. A device called a transducer is coupled with the part, and both sends and receives the mechanical sound waves. These waves are passed through the part and back again in order to detect flaws. Transducers are made in limitless numbers of sizes and shapes. The two most common waves produced are the straight beam and angle beam. The most common application for the angle beam is testing welds where the reinforcement would interfere with a straight beam transducer. The angled beam allows the transducer to be placed to one side and allows the entire weld to be inspected. This plays an important role in detecting discontinuities and flaws in welds on pipe and tubing. Couplants are used to eliminate the air between the transducer and the specimen to ensure proper transmission of the sound waves. They can consist of a variety of liquids, gels, or pastes. Sound waves travel into the specimen, and if they are interrupted or reflected, the transducer will receive an echo. It then sends the signals to the ultrasonic unit, amplifies them, and displays them on a screen. This screen is known as a cathode ray tube, or CRT. The display consists of a straight baseline. If any sound waves are interrupted, a break will appear in the baseline, referred to as a vertical pip. The pips that appear on the screen can be interpreted by inspectors to determine the depth and location of a flaw. The large pip on the left of the screen is called the initial pulse and represents the top surface of the specimen. When the sound waves travel through and are reflected back to the transducer, another pip occurs to the far right, called the back reflection. This represents the bottom surface of the specimen. Indications of a discontinuity or flaw are displayed as any pip signal in between the initial pulse and the back reflection. To demonstrate this, we will use a 4-inch block with a small pre-drilled hole toward one end. Now notice the initial pulse located on the left and the back reflection to the far right. If we now move the transducer slowly across the block and over the hole, we can see a vertical pip occur at about the 3-inch mark on the baseline scale. This tells us the flaw is 3 inches deep into the material. The height or amplitude of the pip will give some indication as to the size of the flaw. The higher the pip, the larger the reflected area of the flaw. Observe the difference between a large hole and a small hole at the same depth. Unlike other non-destructive tests, one of the most outstanding features of ultrasonic testing is its capability of accurately determining the location and depth of flaws. It can be used on practically all non-porous metals with a fair amount of speed. The equipment needed is normally small and can often be operated by battery, which makes it convenient for field applications. Among the few disadvantages of the method is that it does require a highly trained and skilled operator, and it is difficult to contact test complex configurations and rough surfaces. Also, the equipment must be carefully and correctly calibrated prior to use. This is normally performed by use of a standard reference block, which acts as a test pattern to properly tune the equipment. Permanent records are not provided with this particular type of inspection, so like other methods, accurate reports must be completed. Immersion testing is a variation of the contact method used quite often in the testing of larger components. The test is conducted with both transducer and part submerged in water. The water acts as the couplant and allows the signals to be transmitted into the part. It is recommended for testing complex components and is used extensively in the aircraft industry. In conclusion, with proper equipment, trained personnel, and properly written test procedures, ultrasonic testing can be a very valuable tool used for the inspection of weldments.